This video goes with Kuta handout number 11, where we're still solving inequalities and then graphing them. And I really want to focus on the problems that have fractions in them so that students know how to isolate the variable when we have a fraction. So some of the examples I'm going to do will really focus on that. But I want to do problems 1 and 2 to begin with. So problem number 1, I'm going to rewrite it. I have 4 is greater than or equal to some number x divided by 8 plus 3. And once again, I go through certain steps when I solve inequalities. The first thing I do is I try to find out what side of the inequality is the variable on. And I notice that the variable x is over on the right-hand side of the inequality, so that's where I want to isolate it when I'm done. And then I got to decide whether I'm going to flip the sign. Well, I have to look at the integer that's associated with the variable. We could remove that 8 from the bottom of the denominator and make it a coefficient of x. We'll talk about that in later lessons. But right now I notice that that's a positive 8. So that's what's associated with the variable. If that was a negative number, I would flip the inequality sign. If it's a positive number, I keep it the same. I know that this is a positive 8, so the sign's going to stay the same. So when I'm done, x is going to be less than or equal to my answer. So now I'm just trying to isolate the variable. So as I look, I'm thinking, okay, how am I going to get rid of that 8 and the positive 3? I'm always saving what's with the variable, what's associated with the variable for last. So I'm going to do a negative 3 first. That requires that I only do the same thing on each side of the inequality. So I'm going to subtract 3 and put a negative 3 with both of these numbers. Here's my sum line, so I can simplify. 4 positives and 3 negatives make 1 positive. I'm not going to have to flip my inequality sign, so that's greater than or equal to x divided by 8 and nothing is still x divided by 8. And a positive 3, negative 3 cancel out. So now I'm pretty close to getting x all by itself. If I could just get rid of this denominator 8, and I'm thinking, well, let's just see what this means. Some number x divided by 8. So what is the opposite of dividing by 8? I would multiply by 8. So I'm going to multiply by 8, and I'm going to make that a fraction because x over 8 is a fraction. I'm going to go ahead and make 8 a fraction, 8 over 1. And I need to multiply by 8 on the other side of the inequality. But because this is an integer 1, I'm just going to multiply by 8 over here. I need to make that a fraction. Students should know that before they multiply fractions, they can cross-cancel. 8 goes into 8 once. 8 goes into 8 once. Now when I multiply the right-hand side of the inequality, x times 1 is x, over 1 times 1 is 1, and x over 1 is just x. When I multiply the other side of the inequality, positive 8 times a positive 1 is a positive 8. So I've solved it. Now I just need to graph it. And remember, when you graph, you must read the variable first. So I would say x has to be less than or equal to 8. It's kind of like I'm reading backwards. X is less than or equal to 8. All my answers or all my solutions are less than or equal to 8. I'm including the number 8, so I'm going to make it dark or colored in circle. And I will want all the numbers less than or equal to. So I'm going to go in this direction. I'm going to do problem number 2, which was like last night's homework. Problem number 2, I have a negative 4 plus 3k, and all of this is going to be less than a negative 7. Once again, I want to try to isolate the variable, so as I look across the inequality problem, I see there's the k, and when I'm done, k is going to be all by itself. And then I need to know if I'm going to flip this inequality sign. So I look at the coefficient of the variable, and the coefficient of the variable is a positive 3, which means I will not be flipping the sign. So k is going to be less than my solution. All right, I want to isolate the variable, so I have to get rid of the negative 4, the positive 3. Let's save the coefficient for last. What's the opposite of a negative 4? Positive 4. I need to do the same thing on the other side of the inequality. Now I'm going to use my sum line to put things together. Negative 4, positive 4 cancel out. A positive 3k and nothing is still a positive 3k. I don't need the positive sign anymore. I'm just going to bring down my inequality sign, so positive 3k is less than, and then 7 negatives and 4 positives put together is a negative 3. And I'm just about ready to now isolate my variable. Let's see, what's the opposite of multiplying by 3? I would divide by 3. Need to do the same thing over here, divide by 3. Remember, the reason why I divided by a positive 3 is because, or the same number, the same coefficient, I should say. A positive divided by a positive makes a positive. And then 3 over 3 is 1. So there really is my 1k. And we really don't write the coefficient 1, but there's my 1k. You know, we don't really need that 1 there, so I'm going to erase it. I'm just going to leave the k. Looks like I lost part of it. So there's my 1k. And now let's do some math over here. What's a negative 3 divided by a positive 3? Negative 1. So I want to go ahead and graph this. Remember, I need to read the variable first. All my solutions k have to be less than a negative 1. It does not include the negative 1, so I have an open circle, and I want all the answers or all the numbers less than a negative 1. So I would graph it in that form. I'm going to give an example of 2 more fraction problems. Problem number 5, as I rewrite this, I have 3 is less than or equal to some number p divided by 4 plus 5. Okay, I'm going to isolate my variable p. It seems to be on the right side of the inequality, so when I'm done, p is going to be all by itself. Remember, the 4 in the denominator is positive, so that means the sign will not flip. So I'm going to leave it in the same direction. And now I need to get rid of 2 things, the denominator 4 and a positive 5. Remember, let's save what's isolated or what's associated with the variable for last. So what's the opposite of a positive 5? Negative 5. Let's do the same thing over here, negative 5. There's my sum line. 3 positives and 5 negatives is a negative 2. I'm not going to be flipping my inequality sign, so that's going to be less than or equal to some number p divided by 4, and a positive 5, negative 5 cancel. Okay, now I want to get p all by itself, so what's the opposite of dividing by 4? I would multiply by 4. I'm going to make this side a fraction. And over here, this is an integer, so I'm just going to multiply by a positive 4. Remember, these cancel. So p over 1 is just p. I got p all by itself. What's a positive 4 times a negative 2? A negative 8, and I want to graph that solution. Remember, I have to read the variable first. So all my solutions p have to be greater than or equal to a negative 8. I'm kind of reading backwards. P is greater than or equal to a negative 8. So because it's greater than or equal to, it includes the number negative 8, and I want to graph that in the negative direction on the number line. All my solutions have to be, they have to be greater than or equal to a negative 8. So I think I graphed that the wrong way. So let's start that again. All my solutions have to be greater than or equal to a negative 8. So once again, I'm going to color in my circle. But I want all my solutions to be greater than or equal to a negative 8. And I'm down to my last problem. The last problem I'm going to do, I'm going to rewrite. A negative 3 is greater than or equal to some number divided by 2 minus 5. Well, let's see, I'm going to try to isolate the variable. So it's on the right-hand side of the inequality. So when I'm done, x is going to be all by itself. I'm looking to see if I need to flip the inequality sign, but the denominator 2 is positive, so that's going to stay the same. So I'm not going to be flipping the sign. Let's see if we can get x all by itself. I'm going to save the 2 for last. So what's the opposite of a negative 5? Positive 5. And do the same thing over here, positive 5. Let's see, 3 negatives and 5 positives is 2 positives, greater than or equal to some number x divided by 2. And my negative 5, positive 5 cancel. What's the opposite of dividing by 2? I'm going to multiply by 2. I need that side a fraction because x over 2 is a fraction. I'm going to multiply by 2 over here, but I certainly don't need a fraction on this side. So remember, the 2's canceled. So x over 1 is just x. 2 times 2 is a positive 4. Now when I graph this, I have to read the variable first. All my solutions for x have to be less than or equal to 4. So because they're less than or equal to 4, it includes the number 4, and I need to go in the less than direction.